everyone, and welcome to Jam Academy. We have an interesting example before us. A man of mass 2m pushes a piano of mass m up an inclined plane at constant speed. The phrase here, constant speed, is very important. Calculate the work done by him, the normal force, and the gravity on the piano. Remember the definition of work. Generally, work done is equal to the force multiplied by the displacement of the point of application of the force multiplied by the cosine of the angle between the force and the displacement vector. The displacement in this case is the displacement of the point of application of the force. You may be wondering, what is the point of application of the force? The point of application of the force is the point where the force is being exerted. In this case, the point of application of F is this particular point. Now, why did I circle or why did I underline the phrase constant speed? If the piano is being pushed up on the inclined plane at a constant speed, it means that the sum of forces acting on the piano is zero. In other words, there is no net external force acting on the piano. And that is really helpful because it will help us to calculate the magnitude of F. Now, this is an exam question I gave before, and the very part A of the question for you was for you to derive an expression for F. So let's start by doing that. Whenever you're given a problem that involves forces, my recommendation for you is to start by drawing a free body diagram. We have the weight of the piano acts vertically downwards, so this is mg. The normal force acts vertically upwards, so this is the normal force F. Now obviously F acts along the plane. Now we are assuming here that there is no friction. In other words, the inclined plane is smooth. What you can see is that this angle is theta. That means that we can resolve the weight of the inclined plane, the weight of the piano into two components. You have the components, this will be mg cosine theta, and this will be mg the sine of theta. Now I'm going to choose my positive direction to be along the inclined plane. This is my x direction and this is my y direction. That means that the piano is being pushed along the x direction. So if we do that, we know that the sum of forces along the x direction will be equal to F minus mg, the sine of theta. All of this should be equal to 0. It's equal to 0 because the piano is being pushed up the plane at a constant speed. What this means is that F is equal to mg, the sine of theta. So this right here, my friends, represent the force F exerted on the piano. So the next question would be for us to calculate the work done by F. So the work done by the man is the work done by the force F because the person exerts the force F on the piano. So if that is the case, the work done by F will be equal to F multiplied by the distance up the inclined plane, the cosine of the angle between F and the displacement of the piano, which is just 0. So this means that the work done by F is just Fd, which is just going to be mg d, the sine of theta. So this is the work done by the man. If you've noticed, we haven't used the mass of the man. Now the next question is for us to calculate the work done by the normal force. The work done by the normal force is just the normal force multiplied by d, the cosine of theta. Understand that theta is the angle between the force and the displacement vector, and in this case it is 90 degrees. So this means that the work done by the normal force is 0. Now the last thing that we need to do is to calculate the work done by gravity. Now the work done by generally, the work done by a force F is equal to F multiplied by the displacement delta x multiplied by the cosine of the smallest angle between the force and the displacement vector. Remember, the smallest angle. So the work done by gravity, Wg, let me use a different color. So the work done by gravity, Wg, is just going to be equal to the gravitational force mg multiplied by that distance d, the cosine of the angle, I'm going to put here alpha, between the cosine of the angle between the displacement vector and the force, and that angle, this is the angle alpha. If you look carefully, theta plus alpha is equal to 90 degrees, which means that alpha is equal to 90 degrees minus theta. So cosine alpha will be equal to the cosine of 90 degrees minus theta. The cosine of 90 degrees minus theta. This is equal to cosine of 90 degrees, cosine of theta plus the sine of 90 degrees, the sine of theta. Right here, this is 0, this is 1, so this is equal to the sine of theta. Hence, the work done by gravity will be equal to mgd, the sine of theta. This is the work done by gravity. Now, another way that you could have seen this beautifully is the fact that, if you recall, in our previous lesson, we did define work mathematically as the component of the force in the direction of the displacement multiplied by the displacement, as the component of the force in the direction of the displacement multiplied by the displacement. Sorry, there's a negative sign here. So this is negative, and there's a negative sign here. So if you look at this diagram, this is the component of weight in the direction of displacement, and so alternatively we could have Wg will be equal to mg sine theta multiplied by d multiplied by cosine of 180 degrees, which will be equal to negative mgd sine theta. As simple as that. Thank you so much, fellas. If you have any questions regarding this problem, I will appreciate it if you ask in the discussion forum below. Thank you, and bye-bye.